Okay, yesterday we talked a lot about polynomials. Okay, do you remember what kind of actions, what kind of operations we did with polynomials? Adding. What else? Subtracting. What else? We did multiplication. That's all we did yesterday, right? Addition, subtraction, and multiplication. So logically, the next thing would be division, right? Except if you read through my teaks over there on the wall, remember? Division's not there. Okay? Polynomial division is in the pre-cal class. So those of you who are taking pre-calculus next year, you guys will get to do polynomial division. Now I think polynomial division is pretty fun. It's a real quick pattern. You get to even make that sound when you do it. Okay? But we're not doing division here in Algebra 2. Okay? We are, however, going to do factoring. And it's kind of an opposite of multiplication, or an inverse operation of multiplication, not an opposite, sorry. Okay? It seems like division would be the opposite of multiplication, right? And it is, good. But factoring is also a way to break things down. Okay? So, in Algebra 2, we do factoring mostly of 2-term polynomials, 3-term polynomials, and 4-term polynomials. Okay? We could do more than that, but we're not going to. Okay? 2, 3, and 4 terms polynomials is what we usually factor. Okay? So, to start off with, we're going to start off with just in general. Okay? This could work for 2 terms, 3 terms, or 4 terms. I'm going to do some examples just in general, the very first thing I want you to think of. Okay? So, if I say 2x plus 12, and I ask you to factor this, first of all, tell me how many terms there are. There's 2 terms, right? What's separating those 2 terms? An addition sign. Okay? In this case, it's an addition sign. What else could separate the terms? A subtraction sign, right? Okay? So in this case, it's an addition sign. But tell me, this is, guys, even back from, I think it's 6th grade. I'm not for sure, but I think it's 6th grade when you talk about this for the first time. And usually you called it by some initials. Okay? Most of the time, hopefully you knew what the word meant, but usually you called it by its initials. And those initials were #GCF. Anybody remember what GCF it means? Greatest common factor. Okay? Greatest common factor. So look at these 2 terms right here and tell me what the greatest common factor is. What are they both divisible by? 2. So if I factor or divide a 2 out of each term, what do I have left? X plus 6. And then I'm done. I can't do anything else, can I? So another problem. What if I had 3xy plus 5y? What do these terms have in common? A y, right? That's the only thing they have in common. 3 and 5 aren't divisible by the same thing, but I can factor a y out of each term. What's left? A 3x and 5. And then I'm done, right? Okay? What if the problem was even harder? And it was like 3x to the 3rd plus 5x squared y plus 10x. It's just x, isn't it? But how many terms does this one have? 3, right? Here's 1, here's 2, here's 3. So if I factor just an x out of each term, what's left when I divide this term by x? 3x squared. Very good. What's left from this term if I divide by x? 5x xy, so plus 5xy, and what's left when I divide by x? Plus 10. Perfect. So GCF, I want to look for GCF every time. And what does that stand for? Greatest common factor. Okay? Now, let's get specific a little bit as to two terms. We know we're going to think about GCF at the beginning of every problem, right? Now I need to focus on just problems that have two terms. And there's some special. These just had two terms. We just factored out GCF and then I was done because I couldn't do anything else, right? But there's some special things that can happen with just problems with two terms. They could look like this. X squared minus 25. Anybody see anything special about any of those numbers? 25 is a squared. Is that what you said? I agree with that. And in fact, that's very special. Is the other term squared? Well, guys, it's called x squared. What do you think? Okay? So both of these are squared? Wait, how do you know that there's two terms here? They're separated by a sign, right? Either an addition sign or a subtraction sign. And specifically, this particular problem is separated by a subtraction sign. Guys, there's a special kind of problem when you have two terms that are both squared and there's a minus sign in between. That's called the difference of two squares. It's the difference of two squares. Or just the difference of squares. You okay with that? When you have the difference of squares, you can go straight to the answer. There's no messing around. Straight to the answer. Two binomials. The two binomials that you get, the same thing is going to go in the front of each binomial. And that's going to be the square root of this term right here. What is the square root of x squared? X. So that means x is going to go here, x is going to go here. Okay? What do you think is going to go in the second two terms? Why do you think it's 5? It's the square root of 25, right? So what are we missing? The signs, right? Okay? For the difference of squares, the signs have to be opposite. Now some of you are pretending like you remember this. Are you being a really good pretender or do you actually remember this? Very good. I'm glad about that. Okay? So then let me throw you a curveball. Is that all right? Well, I'm going to do it anyway, so get ready. Is that the difference of squares? Well, I heard a yes and I heard a no. What you need to know is that one of those is right. Okay? First of all, is it a difference? Second of all, are these squared numbers? Guys, I get that x squared is squared, but is 2 a squared number? Remember when we're talking about a squared number, I say what times what equals that number. Tell me what times itself equals 2. Nothing. Tell me what times itself equals 72. Nothing. So what should we have thought of first every time? Does it have a greatest common factor? What is it? 2. If I divide a 2 out of each term, what am I left with? X squared, good, minus 36, good. Wait, is that the difference of squares? Yeah, it is, isn't it? Okay, so from there I can go to my two binomials. What goes at the beginning of each binomial? The square root of that term, which in this case is x. What goes at the end of each binomial? The square root of the second term, which in this case is 6. Now, I just tried to trick you. Did it work? For the record, the answer I have written down is correct. But I tried to trick you. What did I do? I switched the signs, didn't I? In this top one that we did first, I put the plus sign first and then the minus sign. And in this answer, I put the minus sign, then the plus sign. Why did I do that? God bless you. Because why? To show it doesn't matter. That's exactly right. Okay? It doesn't matter what order we put the signs when we're doing the difference of squares, as long as they are opposite. Okay? What about this one? This is one that people see as not so easy sometimes, although it really is. Is it the difference of squares? Yes, if it is, then I can go straight to my binomials, right? What goes in the front of each binomial? The square root of that. What is the square root of that? 2x. Very good. What goes in the end? What goes in the second part of each binomial? 7 and plus and minus. Now guys, how do I know that this is right? I haven't talked about this. I should have, starting from the very beginning. How do I know that this is right? I could check it, couldn't I? I could say 2x times 2x is 4x squared. I could say 2x times negative 7 is negative 14x. I could say 7 times 2x is positive 14x. And I could say 7 times negative 7 is negative 49. And what happens with negative 14x plus 14x? That's 0, isn't it? What am I left? 4x squared minus 49. Is that what I started with? Then that's the right answer. Okay? Any questions about that? So what about this one? Is that the difference of squares? No. It's not? What times what equals 121? 11. Okay. What times what equals 1? 1 times 1 equals 1? So 1 is a squared number? Yeah. So is this the difference of squares? Yes. Go to your binomials. What goes here? Which is 11x. And here? 11x. What goes here? And here? Signs? So maybe minus and plus this time, because we did plus and minus last time. Okay, so 3 times in a row I've tried to trick you. One time I almost succeeded, but you fixed it. So can I try one more time to trick you? Is it the difference of squares? Then why is she saying no? I heard lots of yeses and I heard one no. It's not subtraction. How can it be the difference of squares if it's addition here? What is this? It's not the difference of squares, it's what? The sum of squares. Very good. And you guys are going to like these a lot. You know why? They can't be factored. Some of you were thinking it would be 5x plus 9 and 5x minus 9, right? That's what you were thinking? Oh no, that's what it was before, so maybe you were thinking they should both be plus? Okay, so 5x times 5x is 25x squared. 5x times 9 is 45x. 9 times 5x is 45x. And 9 times 9 is 81. Guys, what is 45x plus 45x? 90x. This doesn't have a middle term. The first and last are right, if I write it down right. The first and last are right, but this one has a middle term and this one does not. Are those the same? No. Okay? And if I make them negative, make them both negative, because if I multiply negative 9 times negative 9, doesn't that give me positive 81? Guess what happens with the middle terms then? Yeah, they're both negative 45, right? They're both negative, so I still have a middle term. That's why this kind of problem is prime. Does that make sense? Okay. So far we've talked about greatest common factors. We've talked about difference of squares, and we've talked about sum of squares. Because what are we doing today again? And how do you know we're factoring? Oh, because you wrote it down already in your lesson plans and it's on the board, right? Excellent. I'm so glad you can read. Okay? So here's something else that might happen. What's going on? Is this a difference of squares? It's a difference. I agree with you there, right? It's clearly a difference. What is it the difference of? Mm-hmm. And what do you think it means by cubes? You think we're going to play with some blocks now? No. Okay? Squares means what times what equals the number, right? That's what a squared number is. What's a cube number? What times what equals that number? So tell me, what times what equals x cubed? X, right? Now what times what equals 8? 2, right? So these can be factored, and if you want the formula for this, it's in your worksheet. I have to be honest, I don't know the formula. I know the pattern. And if I had to, I could write down the formula for you because I know the pattern. Does that make sense? Okay, so I'd like to teach you the pattern if that's okay. If you want to go ahead and memorize the formula, you go right and knock yourself out. Okay? But let me teach you the pattern. When we have the difference of cubes, we end up this time with a binomial and a trinomial. Dun dun dun. Okay? Binomial and trinomial. What do you think would go in the binomial? Any ideas? You think maybe a square? Anybody else think anything? Maybe an x? Because like in our binomials of our difference of squares, it was the square root that went right here, right? Well, if we're doing difference of cubes, wouldn't it make sense that our cube root goes here? So what goes? An x goes here, and what goes here? A 2. Okay? Now, here's the pattern I was talking about. Cube roots go in the binomial. Can I show you the pattern for the trinomial? Okay? If this is the first term in the binomial and this is the second term in the binomial, to find the first number in the trinomial, I want you to square the first number. X squared. So it's the first number squared. To get the second number, I want you to multiply the first and the second. 2x. Very good. And the last term in the trinomial, I want you to square the second number. 4. What's missing? The signs. Okay? What number was in the problem? What sign was in the problem? So that's going to go here. The next sign is going to be opposite of that. And the last sign, always plus. Now, you guys in math know how I feel about saying always or never, right? There's always exceptions. It's like in grammar, right? There's not one rule that works for every single time because there's always an exception. I before E, except no, it doesn't always do that way, does it? Okay? But when we're factoring difference of cubes and you have a binomial and a trinomial, the first sign's the sign from the problem, the next sign is opposite, the last sign's always plus. Okay? Does that make sense? Is this an easy pattern to figure out? Then how about if we skip all the easy pansy problems and go right to one that's not so pansy-ish? You up for the challenge? Yes, I am up for the challenge, for the record. So let's do this problem. 125x cubed minus 64. Is this the difference of cubes, first of all? What times what times what equals 125? 5. Very good. Now, people get very confused by this because when they see this, what's the first thing they think? Yeah, 8 squared. Right? That's 8 squared. I know that. That's 8 squared. Except I'm saying, is it the difference of cubes? Is 64 a cube? What times what equals 64? 4. Very good. Okay? So I need a binomial and a trinomial. What's going to go in the first blank of the binomial? Close, Lacey. Yeah, if you guys will combine your answers, you'll get it right. It's 5x. Okay? Up here it was difficult because we didn't have a coefficient here and we just took x, right? Whatever's here, I have to take the cube root of that whole number. So I get 5x. Does that make sense? Excellent. What do you think goes in the second blank? 4. Very good. Right? Now follow the pattern. What goes in the first term of the trinomial? That's so close. But the same way that I had to take the cube root of this whole number to get here, I have to square this whole number to put it here. Right, so it's not just 5x squared, it's 25x squared. Okay? What goes in the middle blank? Close. 20x. It's just 5x times 4, so it's 20x, right? Okay? And what about the last term of the trinomial? 16. Very good. So what's missing? The signs. Man, you guys, so this problem, in the problem it's a minus, the next one's opposite, the next one's plus, right? You guys got that really fast. Are you feeling confident in this? Okay, then this is what I'm going to do. I'm going to give you this problem. This problem has 3 different things than we've talked about yet with difference of cubes. Okay? 3 different things that we're going to talk about in one problem. You okay with that? Good. I appreciate that you're accepting my challenges. Okay? Oh, wait, what? It's not a difference. What the heck? Are we allowed to have the sum of cubes? Yeah, we are. Okay? So this is a little different. It is the sum of cubes. Good job seeing that, by the way. Okay? You can factor the sum of cubes. You cannot factor the sum of squares. It's prime. But you can factor the sum of cubes. But guys, is this the sum of cubes? Then tell me what times what equals 16? Nothing. What times what equals 2? Nothing. Oh, what did we forget to think about? GCF, right? Our greatest common factor. Does it have a greatest common factor? 2. Factor out of 2, what's left? 8m cubed plus p cubed. Very good. So the first thing I wanted you to know, remember I said there was 3 things. The first thing was that it's not difference, it's sum, right? You caught that. Good. You didn't let me trick you. The second thing was GCF. It had a greatest common factor that we had to factor out first. The last thing is, this is the time where people normally panic because it has an M and a P. Oh no! You're not panicking. I'm proud of you. Let's go on. Here's the good thing. When I taught you how to do difference of cubes, I didn't teach you a formula, did I? I taught you a pattern. And the good part about that, the good news, is that sum of cubes follows exactly the same pattern. So we end up with what? Binomial, trinomial. Good. What goes here in the binomial? The cube root of this term is 2m. Excellent. The cube root of this term is p. So what goes in the first term of the trinomial? 4m squared. Very, very good. What goes in the second term of the trinomial? 2mp. And the third term of the trinomial? P squared. Now don't let yourself be tricked. How do the signs go? Oh my gosh, you guys are amazing. Why is this a plus? Because it's the sign from the problem, right? And the second sign, why is it a minus? Because it's opposite of the first one. And the last one? Always plus. Very good. Okay? So those are the special types of two term polynomials. Polynomials with two terms, binomials, right? So the next thing I want to do is show you what happens if there's 4 terms. Can I do that? I need to show you what happens if there's 4 terms. Okay? Now, I know what you're thinking. You're like, oh, we skipped 3. I know that. I promise I do. Okay? I know. So here, let's do this. 12xy plus 2x plus 30y plus 5. And now some of you just gave me the look of like this. Kill me now. Okay, first of all, that is illegal, and I don't want to, because I like most of you. Okay, I like most of you. So, but I don't want this to stress you out. I don't want this to be a hard problem. So when there's 4 terms, I want to group my terms. And the way I want to group my terms is like this. Let's just group the first 2 terms together. Well, guys, all this is just like the first couple problems I showed you that you were so good at. What is the greatest common factor between these 2 terms? 2x, right? What's left when I divide this first term by 2x? 6y, very good. What's left when I divide 2x by 2x? 1, very good. Can I do anything else? Is this the difference of squares or sum of squares or difference of cubes or sum of cubes? No. Then I just ignore that and just look at the second set of 2. What's the greatest common factor of these 2? 5. What am I left with if I divide this term by 5? 6y and 6y plus 1. That's familiar. Oh my goodness. If you thought that blew your mind, wait till you see the answer. That's the answer. So some of you are looking at me strange, and I know you normally do that anyways, but let's make sure that it's not because of the answer. Where did this come from? It's what I factored out of the first 2 set of terms, right? Where did this come from? It's what I factored out of the second 2 terms. So whatever I factored out, I put together as a binomial. And then, what did they have in common? Yeah. Now, at this point, guys, the most common question that people ask me is, where did the other 6y plus 1 go? Because in this step, there's 2 of them, and in the answer, there's only 1. Can I make it real to you that there's really only 6y plus 1? Can I make it make sense? Let me try. Okay? This is the answer. First of all, are you clear with that? Okay, so the next step I write, I'm going to be checking my work. How do I check my work? I distribute, don't I? So I say 2x times 6y and 2x times 1. which could look like this, right? It could look like that. If I say 2x times 6y and 1, I could write it like that. And then I'd say 5 times 6y plus 1. Oh my goodness. No doctors in the house. Okay? And then at this point I could actually distribute to the multiplication and get back up to this last step, couldn't I? Okay, so do you see that there's really only 6y plus 1? They're just both using it. Does that make sense? Okay, let's do another one. But when I do the next one, I'm going to make it easier. Is that okay? Because guess what, guys? They don't get much harder than this one right here. They really don't. Okay? X squared plus 8x plus x plus 8. First of all, I need you to know that this is called factoring by grouping. Does that make sense? It's called factoring by grouping. We grouped the first two terms, we grouped the second two terms, and then we grouped what we factored together. Does that make sense? Okay? Because of the fact that we're pulling something out of each term and then grouping it together in a last parenthesis and a last binomial, that means we have to factor something out of each two sets of terms, right? So what's common in these first two? X, right? So x, when I divide out an x from each term, what am I left with? X plus 8. Can't do anything else with it, can I? So let's just look at the last two set of terms. I have to factor something out, but what's the greatest common factor of these two? 1. Normally, when it's a 1, I don't have to write it, do I? But I need to right now, don't I? I have to factor something out because I have to have something for that last binomial. When I divide each term by 1, I just get x plus 8. What did I factor out? An x and a 1. What did they have in common? X plus 8. Now, earlier they said to me, are these always plus? And that's a good question. It really depends on the problem, doesn't it? Okay, so look at this problem. X squared plus 7x minus x minus 7. Well, what's common in the first two? X. What's left? X plus 7. Very good. What's common in the second two? Now, time out. I said when we write our answer, we say, what did we factor out and what did they have in common? Guys, that implies that these two have to be the same, doesn't it? They have to have something in common. What am I going to factor out of these two terms so that they have something in common? A negative 1, right? Not just a positive 1, but a negative 1. When I divide negative x by negative 1, I end up with x. When I divide negative 7 by negative 1, I end up with 7. Now are they common? Good. What's my answer then? X minus 1 and x plus 7. Very, very good. Okay, any questions about that? Okay. Now, the last thing I want to do for you is 3 terms. Okay, we did special things of 2 terms, special things of 4 terms. Now I need to do some 3 terms. But you need to be aware that I'm only showing you today the easy ones of 3 terms. Okay? The not so easy ones of 3 terms is tomorrow's lesson. Alright? So the easy ones of 3 terms, oh, and it's going to be very clear which ones are the easy terms of trinomials, because this term at the very front is going to be a 1. There's not going to be a multiplier on your x squared term, or just your squared term, just in general. Okay? So, you ready for this? This is a shortcut. Okay? You know how I feel about shortcuts. I don't want to teach them to you if they don't work every time. Okay? Except the shortcut works every time if this is a 1. If this is not a 1, you cannot do the shortcut. And that's what I show you tomorrow. Deal? So I feel kind of on the fence about showing you this way, but it's really helpful, so I'm going to do it anyways. Is that all right? Nobody cares? Okay, good. Oh, okay, one person. Excellent. So here's what happens. If we have a trinomial, we're going to go straight to two binomials. Okay? As long as the leading coefficient's 1, as long as there's no multiplier here, we go straight to two binomials. So tell me what two numbers multiply to be the last term and add to be the middle term. 2 and 3. Once I know 2 and 3, I can go straight to my answer. X plus 2, x plus 3. Done. Okay? What about this one? X squared plus 10x plus 9. What two terms multiply to be 9 and add to be 10? Three and 3 multiply to be 9 but add to be 6. What multiplies to be 9 and adds to be 10? 9 and 1. X plus 9, x minus 1. I mean plus 1, sorry. Does that make sense? So what about something like this? X squared minus 5x plus 24. What multiplies to be 24 and adds to be negative 5? How about if I make this a negative like it's supposed to be? Is that okay with you guys? That should be a negative right there, that big mess. Multiplies to be negative 24, adds to be negative 5. Negative 8 and positive 3. X minus 8, x plus 3. Now, guys, when we did difference of squares, we were very clear in saying that it doesn't matter where the signs go, weren't we? Doesn't matter where the signs go in problems like this. What if I wrote x plus 8, x minus 3? Well, check our work. X squared minus 3x plus 8x minus 24. When I combine my middle terms, what do I get? Positive 5x. Is that what the problem asked? So does it matter where your signs go this time? Yes. Okay, yes, absolutely it does. All right, let me do one more for you. X squared minus 7x plus 12. Any ideas? Close. She said 4 and 3. That's close. Negative 4 and negative 3. Very good. X minus 3, x minus 4. Now let me ask this question to confuse you even more. Is that okay? What if I wrote x minus 4, x minus 3? That doesn't matter, right? On this one up here, what if I wrote x plus 3, x minus 8? That doesn't matter because the correct sign is with the correct number. That's what's important, right? All right, any questions, guys?